Let us welcome in next lecture of MAT-201, that is integral calculus. So in this lecture, uh, we will see a definite integral as the limit of sum. Actually, it is chapter number 4. Yeah, it is chapter number 4. So first, there is fundamental theorem of difference calculus. So we'll state uh, this fundamental theorem. Statement of theorem is that let the interval AB be divided into n equal parts and let length of each part be h, so that we'll write h as b minus a divided by n, or n as b minus a divided by h, or you'll write nh equal to b minus a. So then, this theorem states that, yeah, this theorem states that integration of fx dx from a to b is equal to limit as n tends to infinity or s tends to 0, h times, in the bracket you'll write f of a plus h plus f of a plus 2h plus up to plus f of a plus nh. So in summation form we'll write this value. So it is limit as n tends to infinity or s tends to 0 is times summation f of a plus rh, where r varies from 1 to n. So here, so what is the meaning of n tends to infinity or s tends to 0? So why these two statements are equivalent? So here already we have seen, so b minus a divided by n equal to eh, or b minus a equal to nh. So since as s tends to 0, or yeah, n tends to infinity, as n goes to infinity, so b minus a divided by n goes to 0, and hence, so as n tends to infinity, s tends to 0. So this is the statement of fundamental theorem of difference calculus. So you'll write, so definite integral as limit of sum. You'll write, so this definite integral, that is integration from a to b of fx dx, as limit of sum. So definite integral as a limit of sum. So this is statement of this theorem. We'll use this theorem to prove some examples. So proof of this theorem. I'm skipping it. So first example, evaluate the following. Yeah. So I have written total 7 examples here. So you have to evaluate. These are finite integrals. So you have to evaluate values of these integrals using fundamental theorem of difference calculus. So you are not using the formulas which you already have seen in previous standards. So directly you have to use just fundamental theorem of difference calculus. So first we will solve first problem, that is integration from a to b of x dx. So here, what is fx? So here fx equal to x. So using fundamental theorem of difference calculus, so this is statement of fundamental theorem of difference calculus. So here integration from a to b of fx dx is equal to limit s tends to 0, s times summation f of a plus rh, r varies from 1 to n, where h is b minus a divided by n. So in if you put fx equal to x, so we'll write this limit as a limit s tends to 0 is times summation r varies from 1 to n, and f of a plus rh, it will be just a plus rh because fx equal to x. So we'll write, you can transfer this limit, yeah, sorry, this summation under this addition, that is summation a plus rh. So you'll write limit s tends to 0 is times summation of a plus summation of rh. So h you can take outside of summation because the summation varies over r, variable is r. So here what is summation of a? If we add a r times, sorry, n times, so what is that summation? So if r equal to 1, so it is a. If r equal to 2, again plus a. For r equal to 3 is a. So we are adding a n times, so that will be just n into a. So yeah, value of this limit will be limit as s tends to 0 s times, so first term will be na plus, so what is summation of r? So addition of first n natural numbers. So already you know. So that will be s times n into n minus 1 divided by 2. It will be summation of r varies from 1 to n. Yeah, this formula is there. That is summation of r. So here r varies from 1 to n. That will be 1 plus 2 plus 3 plus up to it goes to plus n. And all we know that is it is equal to n into n plus 1 divided by 2. So using that formula, so you will get, yeah, since you can write this. So it will be limit s tends to 0 s times na plus s times n into n plus 1 divided by 2. So let us simplify this. So you will get, and again you are putting, so uh, n is equal to, so we are putting value of n. So since nh equal to b minus a, yeah, it is there. So you'll write n, that is b minus a divided by h multiplied by a plus h. Again we are putting n, that is b minus a divided by h, and here again b minus a divided by h plus 1 and whole divided by 2. So let us simplify this value of this bracket, and let us multiply this h in the bracket. So you will get limit s tends to 0 a, that is b minus a times b minus a plus b minus a plus into b minus a plus h divided by 2. So let us take limit as s tends to 0. So b minus a plus s tends to just b minus a. So h will be 0. And what is value of this limit? So b minus a can take outside of the summation, this bracket. So it will be, let us see, it is a plus b minus a divided by 2. So if you simplify this, you will get, that is b minus a into a plus b, or that is b square minus a square. So half times b square minus a square, that will be the value of this integration. And we find this value without using that formula, that is formula of integration x raised to n. So just we use a fundamental theorem, or finite integral as a limit sum. So this is first problem. So we solve example number 1. Yeah, that is first example. Next we'll solve fourth example. See, so fourth example is that is integration from a to b of e raised to x dx. So here again fx equal to e raised to x, and therefore f of a plus rh will be, so just you have to put x equal to a plus rh in fx, so it will be its power a plus rh, or you can write it as e raised to a into e raised to rh. So using fundamental theorem of difference calculus, so what is summation of, yeah, so here we are not using fundamental theorem of difference calculus. See, so afterwards we'll use this. So before that, so just we are finding the value of the summation. So let us find the value of the summation. Summation r varies from 1 to n h times f of a plus rh. So it will be h times, so f of a plus rh, that is e raised to a into e raised to rh. So you can take e raised to a outside of the summation, because summation varies from r equal to 1 to n. So h e raised to a summation e raised to rh. So here you can write this summation term wise. So if you put r equal to 1, so you'll get e raised to h, plus for r equal to 1, so it will be e raised to 2h, plus up to plus for r equal to n, so it will be e raised to nh. So that is h times e raised to a into, in the bracket. So again e raised to h you can take common. So in the bracket it will be, so what is outside bracket and what is inside bracket? So it will be h times e raised to a into e raised to h. In the bracket it is 1 plus e raised to h plus up to plus e raised to n minus 1 into h. So actually, so this is geometric series, and we know the summation of geometric series. So this is geometric series, and common ratio is x. Then what is summation of n terms of geometric series? So using that, it will be h times e raised to a e raised to h, and that will be e raised to h its power n minus 1 divided by e raised to h minus 1. Or you can write it as h times e raised to a into e raised to h, and that is e raised to nh minus 1 divided by e raised to h minus 1. Again here nh is equal to b minus a. So using that, it will be h e raised to a into e raised to h, that is e raised to b minus a minus 1 divided by e raised to h minus 1. Or you can write it as, that is h times e raised to h, and you can multiply this bracket by e raised to a. So you'll get e raised to b minus e raised to a. divided by e raised to h minus 1, or you can take this h to denominator, so you'll write same quantity in the form, that is e raised to h e raised to b minus e raised to a divided by e raised to h minus 1 divided by h. So here using fundamental theorem of difference calculus, so before that, this is value of this summation. So just to we find the value of this summation, that is summation h would be f of a plus rh, r varies from 1 to n, and this value is equal to this. So using fundamental theorem of difference calculus, so what is integration? Finite integration, integration from a to b of e raised to x dx, that is limit h tends to 0, summation r varies from 1 to n, h times f of a plus rh. And the value of this summation is already we have, so we put this value here, and that will be limit h tends to 0, e raised to h. Yeah, it is here, e raised to h, which is outside, yeah, outside of this bracket. So e raised to h in the bracket, e raised to b minus e raised to a divided by e raised to h minus 1 divided by h. So again, see, so we are using here, since what is the limit h tends to 0 of e raised to h minus 1 divided by h, and value of this limit is equal to 1. So using that, you will get uh, yeah, and the limit e raised to h will be 1 as h tends to 0. So what is the value of this limit? It is nothing but just e raised to b minus e raised to a. So this is the value of integration from a to b of e raised to x dx. So this is a required answer. Similarly, you can solve remaining examples, that is example number 2, 3, 5, 6, and 7. So this is the end of this topic, that is finite integral as limit of sum. So I will stop here.